volume of a bottle of water is this one correct to nearest 5 millimeter. Find the relative error. Okay, so again, the first step, you should write our scales. So the scale will be like this, correct to nearest 5 millimeter. So the range here, mass error is half of the. So mass error equal to 5 millimeter divided by 2. So it's 2.5 milliliter. So the relative error, the measured error relative to the mass error. So if you have a longer measurement, the more accurate, because if you're using this ruler, all the errors is 2.5 millimeter. So if you measure bigger stuff, the relative error, the relative thing will be small. So I also would like to use fraction button, 1/320. Peter estimates there are 33 cakes in the box. If there are only 30 cakes, so find the relative error. Actually, for counting, we usually don't count like this. But absolute error is 33 minus 32. So the actual value is 30. Actual value is 30. So it depends on the actual value. It got a 3 absolute error over actual value. Okay, this one, but we seldom use it. So we have 1/10 error. So for NV10, you got a 1. Okay, the weight of a letter is this one. So this 59. The next one, it can be the error, the range is 58.5 to 59.5. So if it is 60, if more than 59.5, we count as 60. Okay, so the maximum error is 0.5. And then find the percentage error, correct to 2 figures. Find the answer, and then finally you correct it to 2 figures, but not correct at the first stance. So mass error equal to 0.5 gram. And the percentage error, you find the relative error and then multiply by 100%. Okay, the measured value is still 59, but not 59.5. 59, okay, 0.5 over 59 times 100. You don't need to press the percent. You put it at last. 0.847%. .847,457%. But the question asks you to correct it to 2 figures. So it should be 0.85%. So the error is not big, less than 1%. Number 13. So you see this a number, 20 seconds, 21, 22, 23, 24, 24.0. Okay. So find the percentage error of the measure time, and then finally correct to 0.1%. So for the maximum error, you just need to go to this one, but not go for this one. Is just for the final answer. So the mass error, so it is 24.0. The next one is 24.2. The previous one is 23.8. Okay. So the maximum error is the half of the. So mass error equals 0.2 divided by 2 seconds is 0.1 second. So the percentage error equal to the maximum error divide the measured value and then times 100%. Okay, so percent means 1 over 100. So someone will say 100 and then want to multiply this percent. And this is not useful at all. Some will say a 2 and then times 100%, and then it's always 2. It will not change anything if you just type percent. So just type 100 is enough. So it's 0.416 and then you add the percent yourself. But it's not correct. But you have to correct the answer 0.1%. So that means 0.4% error. Correct to the nearest 0.1%. And number 15. So exactly the bridge is this long. Suppose it you cannot find its actual value actually. And round this off. 15A 1. Like this one you do it yourself. A1 is 437 meter. The steps I won't show you, you calculate yourself. And then ask you which one is more accurate. And then you will see because this one is smaller. So value in part B is more accurate. And number 16. There's a trapezium shown. All the lengths are measured in a ruler. Right. Okay. So you see this ruler. This 0.1 cm. The FE. So the mass error. Measure of this ruler. If you measure anything, whether it's 5 cm long and 10 cm long, is 0.1 divided by 2 cm. So I have 0.05 cm error. So everyone will got 0.05 error. So it is 2.55 to 2.65. This 1.65 to 1.75. This one is 0.05 to 7.15. Okay. So the possible range of x. Minimum possible error first. Minimum possible error is 2.55 plus 0.05 times 1.65 divided by 2. And the unit cm squared. So press calculator. 2.55 plus 0.05 times 5.445 cm squared. So the maximum value plus C. Find the range, possible range. So the maximum possible area is 2.675 bigger value plus 4.15 times 1.75 divided by 2. So again 4.75 2.15 plus 2.75 plus 4.15 times 1.75 and divide by 2. So it's 0.6375. So the range is 5.445 to 6.0375. Okay.